Ferrogandat Technical University. Lecture, Department of Building Materials and Technologies. Theme, Additives and regulate the properties of concrete, mortar and ceramic mixtures, and additives regulating the setting and curing of concrete, mortar and ceramic mixtures. Lecturer, Associate Professor, PhD, Серова Роза Фейковна. Plan 1. Additives that regulate the properties of concrete and mortar mixtures. A. Sodium abatate. B. Water reducing and water retaining additives. 2. Additives that regulate the properties of concrete mixtures. A. Foaming, plasticizing, and stabilizing additives. B. Modifier and superplasticizers additives. 3. Additives that regulate the properties of concrete mixtures. A. Pore forming additives. B. Melting additives and plasticizing additives. 4. Additives regulating and the setting and hardening of mortar and concrete mixtures. A. Hardening accelerators. B. Retarders. Purpose: to study, know, and the additives and regulate the properties of concrete and mortar mixtures. Additives that regulate the properties of concrete and mortar mixtures. Additives allowed by the construction legislation for widespread use. Pass many tests and checks of the effectiveness of use. After studying the characteristics and the problem of the production and use of additives, their quality and side effects from use. A decision is made on the possibility of their wide distribution. Additives that regulate the properties of concrete and mortar mixtures are divided into plasticizing, stabilizing, regulating the preservation of the mobility of the mixture, penetrating, air entering, foaming, gas forming. Sodium abatate. Sodium abatate is a hydrophobizing additive that introduced into the concrete mixture for the involvement of the smallest air bubbles to improve the mobility of the concrete mixture. Sodium abatate is composition the sodium salt of abatic acid obtained in the form of the powdered or liquid by saponification or frothing with caustic soda. water reducing and water retaining additives. Water reducing additives, substances that allow to obtain a concrete mixture of the required workability with a reduced water consumption. Water retaining additives, the substances that help reduce the water separation of the concrete mixture. Air entraining and gas forming additives. Air entraining additives surface active organic substances and promote the involvement of finely dispersed air informally distributed in concrete with mixed it with concrete. Gas forming additives are substances capable of releasing gas due to chemical interaction with stemmed hydration product. Additives that regulate the properties of concrete mixtures. Additives to improve pumpability, substances that reduce the pressure in the pipeline of a concrete pump and accelerate the passage of concrete mixture through it. Additives that regulate the preservation of concrete mixtures, substances that accelerate or slow down the loss of mobility of the concrete mixture over time. Setting time adjusting additives are substances that accelerate or slow down the process of structure formation of a concrete mixture. Forming, plasticizing, and stabilizing additives. Forming additives surface active organic substances that provide the ability to obtain technical form of the required multiplicity and durability which, when mixed with the components of the concrete mixture, make it possible to obtain concretes with cellular or porous structures. Plasticizing additives, inorganic and organic additives, increasing the mobility of concrete mixtures, increasing the ability of the mortar mixture to retain water, preserving the workability of mortar mixtures when lying on a porous base. Stabilizing additive substances that help reduce the delamination of the concrete mixture. Modifier and superplasticizers additives. Modifier additives of a cement system substances that change the properties of concrete and mortar mixtures. Superplasticizers are chemical additives that increase the mobility and fluidity of the concrete mixture and significantly improve the physical and technological properties of concrete. Additives that regulate the properties of ceramic mixtures, to regulate the properties of clay mass, thinning additives that reduce fire and air shrinkage. As thinning additives, quartz and sand is used for wall products measuring 0.2 2 millimeters. Ground slag, expanded clay, and evaporated waste, aged up to 10 to 25%. Better thinning additives are ground dehydrated clay, heat treated at 700 to 750 degree, chamois crushed specifically based clay at temperature equal to the firing temperature of the product. Crushed baked products. They are administered in an amount of up to 40%. Pour foaming Ink additives. Poor foaming or fading additives are used to reduce the average density of wall ceramic and reduce the composition of high-grade fuel. At the jarring state, they play the role of thinning additives. As burnable additives would sawdust 8-25% ground, anthracite, coke, lignite, leon coal 2.5%, thermal power plant ash up to 15% are used. Melting additives and plasticizing additives. Melting additives mixed with clay substance give fusible compound and reduce the firing temperature of product. Shaded feldspars, nepheline, cyanites, pigmentical, perlite, melting additives and plasticizing additives. Melting additives mixed with clay substance give fusible compound and reduce the firing temperature of product. Shredded feldspars, nepheline, cyanites, pigmatites, perlites, ground, fusible glass, slag, sodium and calcium forfates. Accessories are used as fluxes. Plasticized additives increase the plasticity and cohesion of clays. Such additives include highly plastic clay, bentonites, surfactants waste from the pulp industry, scientific fatty acids accessories. Additive regulating the setting and hardening of mortar the concrete mixtures. The need to accelerate or slow down the setting and hardening of mortar and concrete is due to the peculiarities of the production of concrete work. In practice, concrete work often necessitates accelerating or slowing down the setting and hardening of concrete. For example, when erecting structures from monolithic concrete and reinforced concrete to intensify the rate of concreting, it is necessary that concrete gain formwork faster. High-speed hardening of concrete is also needed during emergency recovery work. At the same time, there are cases when the setting of concrete or mortar is deliberately slowed down, for example, when transported in damp tracked over long distances, pumped by concrete pump, and lying concrete is hot water. Among the additives that regulate the setting of concrete mixtures and hardening of concrete, they are accelerating or slowing down setting, accelerating hardening. Hardening accelerators in monolithic construction when concreting concrete and reinforces concrete structures. In some cases, there is a need to accelerate the growth of strength of laid concrete in order to shorten its exposure time before stripping, followed by acceleration of the construction process. For this, the use of electrolytes is effective additives, accelerators of setting concrete mixtures and hardening of concrete. The main criterion for the effectiveness of additive for setting concrete and mortar mix accelerators is to accelerate the setting process by 25% or more at an ambient temperature of 20 plus or minus 2 degrees. For additives of concrete hardening accelerators according to reliability requirement, it is necessary to increase concrete strength by 20% or more at the end of 1 day of normal hardening. In practice, the following concrete hardening accelerators are more often used: potash P, potassium carbonate, K2CO3. The product is the form of a crystalline white powder, is a salt with strongly pronounced alkaline properties. There is a quick setting of the concrete mixture, obtaining concrete with a large pore structure. The dosage of the additive is up to 5% of the mass of cement. Calcium chloride, calcium chloride 2, white crystalline powder in the form of calcium chloride 2 or calcium chloride 2, 2A2O, hydrolyzed as well as aqueous solutions. With prolonged exposure to air, the powdered spread. Calcium nitrate, CalCNO32, available in the form of crystals of CalCNO32 or tetrahydrate CalCNO32 4H2O. The product is colorless, soluble in water. Nitrate calcium nitrate NaK, a mixture of nitrate and calcium nitrate in a ratio by weight of 1 in the form of the aqueous solution or paste. It is not allowed to mix with LSD solutions. Nitrate calcium chloride NaC, the product obtained by mixed calcium nitrate with calcium chloride in a ratio of 1:1, A yellowish aqueous solution with a density of 1.1-1.3 gram SN3. Sodium sulfate natrium 2SO4, white crystals with a yellow tint in the form of natrium 2SO4, 10H2O, decahydride or anhydrous salt. It is difficult and limited soluble in water. Sodium nitrate natrium NO3, colorless crystal in the form of natrium NO3, here is hydrosulfic, readily soluble in water, decomposes on heating with evolution of oxygen. Lingopen B2 plasticizing action hardening accelerator based on inorganic salt of concrete and mortars. The product is the form of an aqueous solution of 30% concentration or a powder readily soluble in water. It does not contain chlorides, does not cause coloration of concrete, and reinforcement dosage 0.6 to 1.5%. Additament BE2, super strong setting and hardening accelerator used in concrete spinning or repair work. Powder superlamine, the recommended dosage is 2.0 to 4.5% of the mass of cement. Manufacturer Edmund Sika, Germany. The action of accelerators is explained by the fact that they reduce the solubility of calcium OH2 released during cement hydration. This leads to further hydration of clinker minerals and ultimately increases the number of tumors in the cement stone. As a result, the strength of concrete containing an accelerator additive in the first 3 to 7 days of hardening is much greater than the strength of concrete without an additive. Hardening accelerator additives intensifying the process of cement hydration and having a positive effect on the formation of the structure of cement stone based on the data alone. To increase the mobility of the concrete mixture by 2-4 sm or to reduce water consumption by 2-3% for equally moving mixtures. Increase the composite strength of concrete after TVO by 5 to 10% provided that more mobile mixtures are obtained without reducing the composition of water and cement, and by 10 to 30% provided that quality mobile mixtures and obtained with a reduced water consumption. Reduced cement consumption by 5 to 10% provided that equal strength concrete is obtained with a reduced composition of cement and water. Increase the frost resistance of concrete by 0.5 to 1 mark, subject to the receipt of equally mobile mixtures or equal strength concrete. Increase the water resistance of concrete by 0.5 to 1 mark. Retards. Two mechanisms of action of additives retards setting and hardening to concrete is to inhibit the hydration and hydrolysis of clinker minerals, determine the shore release or treat lime into the solution and shut down the coagulation and rapprochement of cement grades and its hydrated neoplasms. As a result of this, the setting rate of water clinker slowed down. The setting of cement paste can be slowed down as a result of additives without interfering with hydration and hydrolysis of clinker minerals, quickly bind free time released from T3S. The retardation of setting processes is also caused by the influence of individual electrolytes which, depending on their content in the cement paste, can interfere with a coagulation of colloidal solution and hydrate neoplasm. According is the reliability requirements, additives that slow down setting must increase the time of loss of mobility of the mixture from the initial value to 2 cm by through time or more. For additives that slow down the hardening of concrete and mortar, the criterion of a decrease in concrete strength by hardening retardants for various binders are nitrile-trimethylenediphosphoric acid, NTP, white crystalline powders readily soluble in water and insoluble in organic solvents. With an overdose, a decrease in the strength of concrete and mortar is possible. The additive is effective for all types of cement, including high aluminate ones. It has a plasticizing effect, does not cause corrosion of reinforcement in reinforced concrete. The recommended dosage is 0.02 to 0.15% of the mass of cement. RSB 500 ISB 500 moderator additive for monolithic construction. Solution for the production of nitrile-trimethyl phosphoric acid does not contain substance that cause corrosion of walls. The recommended dosage is 0.02 to 0.15% of the mass of cement. Feed sugar molasses KP. The product is a waste product of a sugar industry in the form of a drink. Viscous liquid of dark brown color, highly soluble in water. There is a showdown in the strength of concrete and a mortar under the age of 7 days. It has a plasticizing effect, not recommended for pre-skate concrete. Dosage 0.05–0.3%. Milk serum, waste from the dairy industry, which is a yellowish aqua liquid that contains milk, sugar, fat, protein, especially strong retarding effect. When serum is introduced directly into the mortar of concrete mix, it has a plasticizing effect. The optimal amount of additive is 1.5 to 3% of the mass of cement. Additive VZB, adamant VZ6. The additive is a strong moderator for mortars, light and foam concrete. The recommended dosage is 0.2 to 1.7% of the cement mass. Manufacturer Adamant, Sika, Germany. Pozzolit XP 100, Pozzolit 100 XR, additive retarded with plasticizing effect. Liquid from brown to black. The recommended dosage is 0.2–0.3% of the cement mass. Sodium gluconate, salt of gluconic acid, obtained from glucose by fermentation. It has a plasticizing and water-retiring effect. Fine crystalline powdered or granulates from wild of brown. Compatibility biodegradable, soluble in water. Recommended dosage is 0.05–0.25% by weight of cement. In addition to those specified as retarders for setting concrete mixtures and hardening concrete, medium and low plasticizing additives of increased concentration can be used, for example UPB, some organic substance, LST, GKZ2, GKZ11, as well as the addition of 2-water gypsum, a weak solution of sulfatic acid, sugar, syrup, animal glue, and others. The concentration of additives determined by the laboratory, usually 0.2–2%. It should be noted that the use of additives such as FFB and GKZH allows to simultaneously reduce water demand and binder consumption. It should be remembered that the same additive and different dosages can also exhibit different effects, i.e., accelerate or slow down the hardening of concrete. Therefore, the concentration of additives in the concrete mixture established in the construction laboratory empirically must be maintained during the manufacture of the mixture. The amount of additives is used 1–3% by weight of cement. Many of the supplements used is handled employee can be harmful effect on workers. It is especially true for hardening accelerators, chloride salts. Calcium chloride is very dangerous for the skin of the face and hand. Chlorine lime and its solution can release chlorine, which, when ungassed, can cause severe sponsoring. Organosilicon liquids have a strong irritating effect on the skin and mucous membranes. Therefore, it is necessary to carefully observe safety rules when using additive on this type. Questions for self-control. 1. Additive that regulate the properties of concrete and mortar mixtures. 2. Additives that regulate the properties of concrete mixtures. 3. Additives that regulate the properties of ceramic mixtures. 4. Additives regulating the setting and hardening of mortar and concrete mixtures. List of main literature. Thanks for attention.